Exercise 7.5 12th sum. If an initial amount A0 of money is invested at an interest rate or compounded n times a year. So certain amount A0 invested in a bank or some places, interest rate is R and compounded n times a year. The value of the investment after t years is A is equal to A naught into 1 plus R by n whole power nt. If the interest is compounded continuously, that is as n tends to infinite, show that the amount after the t years is A is equal to A naught into e power rt. So in this question, sum of the amount that is A naught is invested, interest rate is R, in a n times a year, compounded n times a year. After t years, that amount will be changes in this format. A is equal to A naught into 1 plus R by n whole power nt. The interest rate is compounded continuously. Compounded continuously means we are going to choose n tends to infinite. That is already given the question. From this, show that the amount after t year is A is equal to A naught in the e power rt. We are going to prove this result. Okay. So first, let y is equal to 1 plus r by n whole power nt. We are choosing that result. Y is equal to 1 plus r by n whole power nt. That equation is given. We are choosing, take it as y. Okay. Next, taking log on both sides. So log y is equal to this nt come here. So log of 1 plus r by n nt into log of 1 plus r by n will come. Then what is the limit is given? N tends to infinite. N tends to infinite. So here n is infinite. So infinite into 1 by infinite. 1 by infinite is 0. Here log 1 will come. Log 1 is also 0. So infinite in 0 form. So apply the limit on both sides. Limit n tends to infinite, log y is equal to limit n tends to infinite, log of 1 plus r by n divide by 1 by nt. 1 by nt, log of 1 plus r by n divide by 1 by nt will come. Okay, because I change this format. Now substitute the limit. N tends to infinite, 1 by infinite 0, log 1 0, so 0 numerator, divide by 1 by infinite, that also 0, so 0 by 0 form. So we get indeterminate form. Indeterminate form means next we are going to differentiate, that is apply L'Hopital rule. So that is equal to limit n tends to infinite, log x is already know 1 by 1 plus r by n, 1 by x, so 1 by 1 plus r by n into differentiate. 1 is 0, r by n, r is constant, 1 by n differentiation is minus 1 by n square, so minus r by n square is divided by, here 1 by t is there, so 1 by t constant into 1 by n differentiation is minus 1 by n square, minus 1 by n square. So cancel the term, minus 1 by n square minus 1 by n square cancel. This t goes to numerator. So what you get? Limit n tends to infinite t into r, let rt divide by, this comes denominator, 1 plus r by n. So this t goes to numerator, rt, this 1 plus r by n comes here, so 1 plus r by n. Now apply the limit. N tends to infinite, n tends to infinite, r by infinite, that is 0, so 1 plus 0 we get 1, so rt will come. Then what is left hand side? Limit n tends to infinite, log y, this log comes outside the limit, so log of limit n tends to infinite, y is equal to rt, y is equal to rt will come. This log go to this side, what you get? Limit n tends to infinite, y is equal to e power rt will come. Y is equal to e power rt. But the given question, what's given? A is equal to a naught into a is equal to a naught into 1 plus r by n whole power nt. That is given, no? So in this part we are assume what? That is y. After applying the limit, what you get? E power rt. So from this we can a naught into e power rt. So we prove this result as e power rt. So finally a is equal to a naught into e power rt will come. So this result we are going to be proved. A is equal to a naught into e power rt.